For this video, we are going to be discussing angle-side-angle triangle congruence. So angle-side-angle is another triangle congruence theorem, and it comes from Euclid's Elements, Book 1, number 26, and it states, if two triangles have two angles equal to two angles respectively, and one side equal to one side, namely either the side adjoining the equal angles or that opposite one of the angles, then the remaining sides equal the remaining sides, and the remaining angle equals the remaining angle. Okay, so what does that sound like in more modern terminology? Well, it says if two triangles have two angles equal to each other, and the sides between the angles are equal, then the triangles are equal. Or instead of equal, we could say congruent. So if I've got two angles equal to two angles, and the sides between them are equal, then the triangles are equal. Okay, and the difference between this and side angle side, which we discussed in a previous video, is that this is a theorem, meaning we can prove this one using side angle side, and we will do that in a few minutes. But first, let's just confirm that this works. So here I have two triangles, triangle ABC and triangle DEF, that I have constructed so that I have two angles, angles ACB and angles ABC, that are equal to two angles, angles DFA, or DFE and DEF, and the sides between them, sides EF and sides BC, are equal. What I need to find out now is, are the other two sides equal, and is the one remaining angle equal? Well, let's find out. So my missing angle here is angle BAC. Let's measure that angle. Okay. Okay, we measure that angle. We see BAC is 68.58 degrees. My missing angle over here is angle FDE. Measure that angle. We see that it's exactly the same. Okay, so far so good. All right, let's measure our missing sides. Okay, so measure of angle BA is 5.39. CA is 2.86 centimeters. Let's measure our two missing sides over here. And we see that ED is 5.39 and FD is 2.86. Well, there we go. We've shown that all of our angles are equal and all of our sides are equal. And all I did is construct these with two angles that are equal and two sides that are equal. So we are confirming that it does work. Notice that no matter how I change my triangle, my congruent measurements, or my corresponding measurements, always stay the same. So we can conclude that this congruence theorem does, in fact, work. Okay, but simply demonstrating it is not good enough. We have to be able to prove this because it is a theorem. So let's go ahead and prove this theorem. So here's how we're going to do that. We're given these two triangles, triangles ABC and DEF, similar to the ones that I just made, where angle CAB and angle FDE are equal, and angle CBA and FED are also equal, and side AB equals side DE. We want to prove that these two triangles are congruent. Okay, so how do we do that? Well, what I want to do is I want to construct some point, let's call it H. Okay, we're going to construct H, put it right here, on ray AC, so on this side length AC, so that AH is equal to DF. Okay, so we're saying AH equals DF. Remember, we haven't proven these triangles are congruent, so we can't say for a fact that AC and DF are the same length yet. But we're going to say that AH and FD are congruent. We're going to construct H especially so that that'll be true. Okay, so I'm going to go ahead and I'm going to connect BH here. I'm going to connect B and H. So I make this other little triangle ABH. Okay, now that I've done that, all right, we know that angle BAH is the same as angle BAC because H is on AC. And that's also the same as angle EDF. Okay, so if that's the case, then we know also that AB is DE by construction. That's how we constructed it. And so we can say, well, if we know all that, then we know that by side angle side, side angle side, side angle side, we know that our two triangles, ABH and DEF, are congruent. Okay, so we've proven that these two triangles, ABH and DEF, are congruent to each other. Okay, well, that's interesting. Now that we have that, we're left with two possible options. Okay, either H is the same point as C, or it's not. And if H and C are the same point, then I'm good. I've proven that ABC and DEF are congruent. But if H is not the same point, then I've proven that they're not congruent. So let's look at that one first. Let's say H and C are not the same point. Okay, well, if that's true, AC and BC only intersect at C, so H is not on BC. Okay, and if H is not on BC, then angle ABH is not equal to angle ABC. But this is a problem, okay? This is a contradiction, because we've proven via side angle side that triangle ABH is congruent to triangle DEF, okay? Which means that angle ABH equals angle DEF. But by construction, we know angle DEF also equals angle ABC. Well, therefore, angle ABH has to equal angle ABC. So it's impossible for H to not be equal to C. And so it must be true that H is equal to C. And if H is equal to C, then ABH is the exact same triangle as ABC. And since we've proven that ABH is congruent to DEF, then ABC must also be congruent to DEF, proving that angle-side angle congruence does work as a congruence theorem. All right, so not that difficult of a theorem to prove. So let's take an example, now that we've proven it, of how to use angle-side angle. So we're given this set of triangles here, triangles ABD and CEB, and we are trying to prove that they are congruent. Okay, and we are given that AD and CE are parallel to each other. We're also given that B is the midpoint of DC. All right, and now we need to prove that ADB is congruent to CEB. All right, well, let's see how we do that. So we start off with our given. AD and CE are parallel, and B is the midpoint of DC. Well, if these two lines are parallel, well, then we know something about these angles here. We can say that this angle, ADB, and this angle, BCE, or ECB, are equal to each other by alternate interior angles. Remember, the alternate interior angle theorem says that when I have two parallel lines that are cut by a transversal, alternate interior angles are congruent to each other. So I could say that this angle, ADB, equals this angle, ECB. Okay? Because we know that because we know B is the midpoint of DC, then we know by definition that DB is equal to CB. All right, so we have we have one angle and our side. Now we need to show that these two angles, ABD and CBE, are also congruent. That's easy enough. We know that they are vertical angles, so we can say that they're equal to each other because of vertical angles. Well, now I have an angle and an angle that are equal, the sides are equal, and the other angles are equal, so I can say that my two triangles, ADB and CBE, or I should write this the same way, CEB, are congruent because of the angle-side angle theorem. And there we go. Now you've seen exactly how angle-side angle works. I've shown you a proof, and I've shown you a worked out example of how to use angle-side angle, so now you may use it to prove triangles are congruent.